So if that's the case, then we gotta solve for what, class? X. Okay? So we solve for x, we're gonna subtract the 2, right? And then take the square root. Let me just write it out. Y equals 2 plus x squared. Subtract the 2, that's gonna be x squared is equal to y minus 2. And then you take the square root on both sides. And so x is equal to, now here's the thing, it's gonna be plus or minus the square root of y minus 2. But because we're in the first quadrant, when we do these things, we're doing this in the first quadrant, we keep the positive and discard the negative. We're gonna look at the positive side of it, okay? So we'll just go ahead and write that out. So therefore, I'm just gonna say x is equal to the square root of y minus 2. The curve looks something like this. If you were to draw it out, it'd be 1, 2, because it got a y-intercept of 2, and it's a parabola because it's an x squared, so it's gonna look something like this. Okay? Got it? And then if I'm rotating about the y-axis, if I'm doing that, then what's happening is it's creating a bowl. Okay? All right? Sitting on top of some quadrants here, okay? Make sense? Sitting on top of the x-axis there. All right? Got the pot, you got, it's 3D now. Okay? Isn't that something? Basically, I'm gonna say this, because it's 3D, your y-axis now becomes the z-axis. We'll see that in Cal 3, okay? All right, this becomes the z-axis. This right here is your x-axis, and this one right here is your y-axis. I think I got that backwards. Are y'all with me? Okay? And so now we're gonna find the surface area of this bowl is what we're doing. Rotate about the y-axis. It's gonna be a totally different calculation than with the x-axis. Understand? The shape of the one that we just found earlier is the same shape. Let's just rotate about the x-axis, okay? So far, so good. All righty. So here we go. So we're in the first quadrant. Let me go put that note. In first quadrant. Okay? So then now I can call this my f of y. My f of y, or g sub y should I call it. Let me call it, well, they call it f of y in the formula. So I'll leave it as f of y. Is the square root of y minus 2. Okay? Now we're going to change that to y minus 2 to the 1/2 because we're about to do some calculus with this. And what we're going to do is we're going to do the derivative. All right? Let me use a different color now. So now the derivative, f prime of y, is equal to what, class? You got to use the chain rule, right? So it's going to be 1/2 times y minus 2 to the negative 1/2. That's the derivative of the outside, right? Times the derivative of the what?
Inside.
Inside. But when you take the derivative of the inside, it's just 1. So we don't have to really, you understand what I'm saying? Deal with it because it's just a 1, right? So it's going to be all of this times 1 because the derivative of the inside is just 1, right? Y'all okay?
Mm-hmm.
Okay. All right, so there's the derivative. Now the problem with this is I don't want the negative power, so I'm going to have to flip it and take it to the denominator. So it's going to be 1 over 2 times y minus 2 to the positive 1/2. Okay? So far, so good? All right. Let me get a darker brown. Okay. Oh, can y'all see that brown?
Yeah, it's fine.
That's fine? Okay. So it's going to be 2 pi. The integral from 0. It ain't 0 to 3, is it, class? Because we're doing the y. So we can't go from 0 to what? 3. So how do we do it, think with this? Well, you have to go back over here and plug in the 0 to 3 into this formula right here to get the what? The y. Are y'all with me? We can do it just by looking at it. If I plug in the 0 into x, what's 0 squared? 0. And 0 plus 2 is what? 2. So this becomes a 2. And then if I plug in 3 into the x, 3 squared is 9, right? 9 plus 2 is 11. So this is going to be y is less than or equal to 11, greater than or equal to 2. Make sense? So it's going to go from 2 to what? 11. And then what's the formula say? The radius is your function, it's your curve. All right, it's gonna be the radical y minus 2. Oh, y minus 2 to the 1/2. No, right? Gotta keep it as, no, I kept it as a radical. Let me keep it as a radical. I can't make up my mind, class, I apologize. That's why I have to have my notes. And then times the square root of 1 plus, okay, the derivative squared, the square root of this, right? So it's gonna be 1 over 2, parentheses, y minus 2 to the 1/2, close parentheses, squared, okay? dy. Right? Okay. When I square that, now again, this is another integral that you cannot do this by hand, all right? 211. Square root of y minus 2. Square root, okay, of 1 plus, if I square this, I'm squaring the 1. 1 squared is still what? 1, right?
Right.
Then I also squared the bottom. 2 squared is 4, right?
Right.
Then I squared that stuff in parentheses, but I'm going to square the 1/2, right? So 1/2 times 2 becomes a 1. It's just y minus 2 to the 1 power, or just y minus what? 2 when you square it. Are you okay?
Mm-hmm.
Okay, dy. Got it? And again, you would plug that into the calculator. The calculator I showed you earlier. I think y'all can do that. If I were you, when you get home, go back, go to the calculator and redo these integrals, all right? Okay, do this integral and see if you get this answer. This is the right answer. I'm not saying it's wrong, just so you can practice giving it. So it's going to be 117.3187. I'm just going to put in parentheses, use calculator. Which you can find this calculator, again, it's in that folder, right, called resource program folder, and Blackboard, all right? Y'all okay, class? Now check this out. I'm gonna show y'all something. I don't have to show you this, but, I don't mean like that. I don't have to show you this because we got the answer, but I want to show it to you anyway, because it's pretty interesting, all right? Check this out. This is interesting. Now, we're not saying we're rotating about the x-axis when I do this, okay? But what's interesting is, you know how we solve for x here? Right? What are we saying x is equal to? Right? Are y'all with me, class?
Right.
We're saying x is equal to what? That, am I right? So what you could have done is leave it in terms of x, even though we're rotating about the y-axis. All because I know that radical y minus 2 is what? It's called the change of variables. You know how you do u substitution? Right? In Cal 1? It's called the change of variables. So in other words, I could leave this in terms of x, which means I would have to take this back into terms of what? This part right here back into terms of what? X, right? Okay, which is basically the derivative of this squared, correct? Right? Right? This is f of x. If I take the derivative of that, it's going to be f prime of what? Of 2x. And if I square that, it's going to be 4x what? So this would become, this right here would become 4x what? Squared, and I would have s is equal to 2 pi. We leave it from 0 to 3, because now we leave it in terms of x. This would have been 1 plus 4x squared dx, and I promise you, you'd get the same answer. If you did it that way. Does that make sense?
To like not change any of the bounds.
You have to change the bounds though.
You kept the original 0 to 3.
No, then the original was from 2 to 11.
Oh, I'm talking about
But
way
yes,
up
you
there.
keep the original bound, yes, if you're talking about, yes. So if I'm gonna leave it in terms of X, I keep the what? The original bounds. Does this make sense?
But your answer is different on the previous example.
Right, because they're still rotating about the Y-axis.
Okay.
You see that? Because if you look at this, is it just 2X here? I mean, is it just X? What is it?
Oh,
on the other?
yeah, no.
See what I mean?
Yeah.
Isn't that crazy? That's weird, isn't it? But it makes sense because what is your just X? It is the radical Y minus 2, see? Oh, okay, I can replace this with just X. But then I gotta take this back into what? The derivative in terms of what? Which is 4X squared. You see?
So those just replace.
Yeah, and you're finding the surface area rotate about the Y-axis, but just in terms of X. Isn't that interesting? Yeah?
That's a lot easier to model.
It is. It's a lot easier to deal with all that than all this other stuff, especially plugging into the calculator.
Yeah, that's good.
Just be aware of that, okay?
So is there some examples where we could, like say, where